All right, let's cover our last two tests. Woo! We've got the ratio and the root test that we get the opportunity to cover. So let's talk about that ratio test first. Ratio test. Let this series of a sub k be an infinite series. And we are going to let r, and this is the key, so figure out the values of r here. Let r equal the limit as k approaches infinity of the absolute value of a sub k plus 1 over a sub k. So this is what's going on. We are coming up with our value of r. Now we're going to have criteria associated with r. So heads up on that. It's coming. Just give me a minute. We're actually taking the limit of this absolute value of the next term in my sequence over what I have originally. All right, so we're taking that limit. So the ratio is fancy talk for fraction, right? So we're making this fraction out of this deal, and that's our ratio test. Okay, so here's the deal. If, criteria number 1, if r is less than 1, the series converges absolutely. Because absolute convergence implies convergence, right? So if I'm taking my absolute value here, then I know that this converges absolutely. If I take this limit, whatever this limit is, if it is less than 1 here, then, and it's absolute value, so I know it has to be positive, right? But if my limit here is less than 1, then the series converges absolutely. If r is greater than 1, including infinity is what the directions say, but we all know that's greater than 1, the series diverges. All right. If, the last scenario here, r equals 1, the test is inconclusive. So try something else. That's what the moral of that story is. All right. Okay. So if it's less than 1, converges absolutely, greater than 1, diverges. Now, let's tap the brakes for just a second. I want to point something out to you. Don't we know if I come up with some values in relationship to 1? What was that other test that we had that's relationship to 1? P-series, right? So look at what's happening here. If r is less than 1, this one converges, where your p-series diverges. So this is opposite. Now, granted, we're taking the limit. It's a whole different test, etc. But I don't want in your head, I don't want you to get confused. So I'm trying to bring it out to you right now. This is in relationship to 1. So will the root test be, by the way. So the root test and the ratio test are very similar. The criteria are going to be the same. This setup is different. Anyway, but all of these are still going to be in relationship to 1. So I don't want you to get confused about which one goes with which because they're opposite of each other. So I just want to bring it up right now so you can pay attention to it as we go through here. All right, let's do an example. Oh, whoa. Here are some tip-offs that I want to put in here before I forget. Use the ratio test when you have factorials and like if you have k to the k power. All right, so if you have like k to the k power, this is when you're going to use ratio test. Now, this word factorials, you guys probably looked at that and was like, what? Are you just making up words now? No, I'm not making up words. A factorial is like 3 factorial. It's that exclamation point at the end. You are multiplying all of the values that you start with 3 and you go down from there. So it'd be 3 times 2 times 1, which ends up being 6. But that's 3 factorial. So if I have 5 factorial, then that would be 5 times 4 times 3 times 2 times 1, and whatever the crap that is, right? 120. So whatever it is, I don't really care, but that would be 5 factorial, which means if I have like n factorial, that would be n times n minus 1 times, right? Are you seeing what's happening here? N minus 2, etc., all the way till we get down to 1. Do you see? Okay, so if I have n plus 1 factorial, I start off with n plus 1, and I'm going to take that times n, times then n minus 1 times all the way down to 1. Do you see what's going on there? So if I have n factorial, then I take that value, subtract 1 to get to the next, subtract 2 to get to the next, etc. If you start with n plus 1, subtract 1 gets you to n, and it goes from there. Now, something I want to point out to you, because this is going to make an impact for us very shortly. Hang on. I got too soon. This is this. So you can actually write n plus 1 factorial as n plus 1 times that n factorial. Do you see that? Because n factorial then lays out all the rest of it. Okay, factorials, you're taking your first value and then you're just multiplying it out from there. All right? Okay, let's do some examples. Here's our first one. Example 1a, I get k equals 1 to infinity, and it's testing if the following series converge, just like normal. 10 to the k over k factorial. Now, here's my tip-off. As soon as I see that factorial, that's my big, huge wee-oo, 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 bells going off, whatever it takes, and that tells me ratio test. All right? Okay. So, with this ratio test now, we are going to take the limit as k approaches infinity of this next term in my sequence. So I'm going to add 1 to each of these terms. So this is 10 to the k plus 1 over k plus 1 factorial. And I divide that by my original. Right? Now what happens when you divide fractions? We kind of did the same thing with our limit comparison test. I'm okay with you skipping this step I just wrote down and going directly to this. The limit as k approaches infinity of 10 to the k plus 1 over k plus 1 factorial times k factorial over 10 to the k. Right? Okay. You can skip this. I would. I'm not going to. That's the only time I'm ever going to write it. So let's do this thing. Now, the whole purpose of the ratio test is so that you have this rational expression that you can start breaking down. I can't solve for that factorial. I don't know how to take the limit of that factorial. That's crazy, right? So we need to simplify this out in order to pull that off. Remember, like bases, you add those exponents. So you can break this up to be 10 to the k times 10 to the first power, right? You don't have to write that one. Over, and we just discussed, k plus 1 times k factorial because you're going down 1. So you have k plus 1 minus 1 is just k. Now, do you see what's happening here? All of this stuff is multiplied. So because everything is multiplied, I can now take k factorials and cancel them out. 10 to the k and cancel that out. And so now I'm just left with the limit as k approaches infinity here of 10 over k plus 1. Now, as k approaches infinity, what does this whole thing go toward? 0. Because k is my only variable and it's in the denominator. Now, what do we know about the relationship between 0 and 1? Less than 1, meaning absolute convergence. Therefore, my series of k going from 1 to infinity of 10 to the k over k factorial, I had to write it and figure out what it was, converges absolutely by that ratio test. Good. All right. Ratio test. You are just multiplying by that reciprocal and working it out. Okay.